Okay, so hello everyone. I'm Rainer Schlitzer from the Alfred Wegener Institute. Together with Sebastian Miroch, today in this webinar, we want to present you new development that are aimed to make it easy to link multidisciplinary data sets with our webODV tool. This work was done within the FAIRES and Blue Cloud programs, and we are grateful to the European Union for financial support. Rob quickly went through the agenda, so we will have a mix of slide presentation, but also live demos in between. Well, the basis for webODV is the Ocean Data View ODV desktop software that has been around since 30 years now. It's available for all desktop systems, Windows, Mac OS, Linux. We are aiming to have native ARM executables in addition to the more traditional x64 whenever those systems come up. ODV desktop is very popular. I claim it's easy to use, has an intuitive, interactive user interface, and it's supporting many plot types, and some of them you can see here on the slide on the left side. Now, the way ODV desktop is operated is users install the software on their local machine, and
Rainer, sorry, I think
we
Rainer, I think we still see only the first slide. Oh no, the second, can it be? I see only the second, the agenda.
That's funny.
Yeah, maybe you need to switch. Yeah.
Obviously, are you seeing the ODV desktop slide now?
Not yet.
No. Rainer, maybe you can turn off your camera to save bandwidth.
Okay, I stop sharing and I will share again, and everybody now has seen my face and my camera is off now. So I share again. Can people see this slide now in smaller size?
It's still loading.
Not yet.
In case we can share on your behalf.
Yeah.
Still loading? Is it still loading?
Still loading. So just a black screen.
Oh my goodness. Whew. Okay, my home internet is back.
Now it's there, so we can see it.
Yeah, now we see Ocean Data View ODV desktop.
Can you still see it?
Yes.
Yes.
And what about now? Do you see the big slide?
Let's give it a few seconds. It's probably still loading. Okay, now it's up. There's a bit of a lag, Rainer, that's the only thing. So maybe during transitions, maybe you can either transition quite a bit early or just give it a few minutes. Yeah.
Okay, so these words about ODV and the popularity and the different plot types that are available. What I was explaining last was the mode of operation. So people have to install the software on the local machine, but the data sets also have to be on their machine. This has some advantages. For instance, you could work without any internet, just like myself in this case. But the disadvantage is some of the data sets are huge and they take up local storage on your machine. And sometimes these data sets are updated regularly. And so every user would have to take care to update to the new version regularly. And this is a disadvantage of the ODV desktop mode of operation. And that's why about 5 years ago, we set about to make a companion named webODV. So is the new slide showing with these server names?
Yes.
Okay. So and we call this webODV, and webODV works differently. The user does not have to install any software, and the data sets also are not on the user's machine, but software and data sets are on specific webODV servers. And this slide has a list of some of these servers that we have set up in recent years, and 3 of them, they are of relevance for this webinar, and we will actually visit them. And on these servers, there's a wide range of important environmental data sets, and some of them we will now revise and tell you what kind of data you can expect on these servers. So do people now see this bluish homepage of webODV Explore? Yes?
Yes, it's good.
Okay, so this is, we are now visiting this first server that is actually operated at RV, where lots of data sets, more than 450 important community data sets, are hosted and offered to the users. And they are organized by compartment in the Earth system. So we have a big ocean contribution, atmosphere, ice, sediment, and rivers. And the data sets, they are organized in a tree-like structure. So for instance, if you are interested in meteorological data, you would left-click on this. You would see the contents of this superset. If you are interested in a given data set and want to know a hint of what is in there, just hover your mouse over it. If that is what you like, dive deeper until you reach the actual data set name, and getting and opening that data set is just one left click on this name, which I don't do now. But in summary, so there are important historical meteorological data. There are historical river discharge data. There are data for core top sediments and a little bit of ice shields. The main core is in the ocean, and I go quickly through. So World Ocean Atlas in its recent version, 23, is available. The previous version is also available. There's a whole number of tracer data sets. For instance, the very high quality geotraces, trace element and isotope data, but also a tritium-helium compilation for the world ocean, and some more. There are sea level data, some optical data, mixed layer data, current meter data, and biogeochemical data. 2 categories where I want to dive in, a big block of hydrographic data. The entire holding of the CCHDO data center in San Diego that has all the ship data worldwide is available here. Legacy geosex data, CLODAP, marine mammals. Maybe some of you have heard about that mammals are now equipped with sensors. This is a global compilation for this. and a data set that we will actually use from Sea Data Cloud project, European project. World Ocean Circulation experiment data also. The second category that I want to quickly go into, carbon. There are quite a lot of carbon-related data sets. And I want to highlight dissolved organic carbon, global compilation for the world ocean, Bermuda Atlantic time series, more than 30 years of time evolution, hot Hawaii ocean time series, and the last one that I want to highlight, the SOCAT data set that has more than 40 million surface observations of FCO2. So for carbon interested people, this is super relevant. We have a second webODV Explore server. This is now hosted at Clermont-Ferrand in France. That is focusing on satellite data and model and reanalysis data. One satellite data set from MODIS Aqua, this one we will actually use. And I will click on this to start this session while I'm releasing sharing and handing over to Sebastian now.
Okay, thank you, Rainer. And hello, everyone, again. And so what I want to do is I want to present another webODV server. And probably a good starting point is our webODV homepage, which you can reach under webodv.rv.de. And here we have a list of our servers, and Rainer has already shown the webODV Explore server. And here we have the webODV providing the Argo data. And this is where we want to have a quick look now. I click on it, and I'm redirected to the Argo webODV, which is available under this URL, argo-webodv.vm.fedcloud.eu. And this webODV is supported by the Blue Cloud 2026 project. So what is different to the Explore server that Rainer has shown is that we need to log into this webODV. So this login needs a couple of steps, and I want to show that. So this is a button named Login with EGI, and this is a single sign-on system you may know from other apps as well. So we click on it, and we are redirected to this EGI check-in service. And what is important now is that you click here on EGI check-in. I click on it, and now we have several options to log in. For example, Google, OrgID, GitHub, some others, or we can search for our institute. For example, I find my own institute, the Alfred Wegener Institute. If I click on, I would be redirected to the RV and could log in with my credentials. Now I will go for Google, which is quite simple. You know that from other apps. You just type in your credentials, and then you are in. So here we are. And here we provide the Argo data, the hydrography profile data from Argo, as well as the biogeochemistry data. And all are updated daily. And this is what I really want to highlight here, that all the data sets are up to date. So we have here, the up-to-date data sets. So let's jump into one of those. I will choose the BGC Argo profiles, click on it, and on the next page, we can choose two different services. One is the data exploration service, which is actually the ODV online, and Rainer will show much more about that. What I want to show is the data extraction service. And the goal of the data extraction service is simply if you want to get quickly data out of it, then this is a very good option. And for this data extraction, you don't need to know anything about the real ODV, because ODV is just in the background. And here we have a simple and intuitive interface. Actually, it's a 3-step process where you can, for example, here zoom into a region of interest. You can even zoom more into it. So, and then if you're happy with your selection of stations for download, you go to the next step, which is the selection of variables. And here you don't, so the idea is that you don't need to download the full data set, but only the data that you really need. So let's say you just want to have pressure and let's say oxygen, because this is what you are interested in. You just click on those variables, go to the next step for the download. And here you can download the data set, the subset, as 3 different file formats, the TXT format, the original ODV format. Then you will get a normal ODV collection, which you can use also with a desktop ODV or a NetCDF. So if I click on one of those, I'm informed that the download is processed in the background and an email will be sent to me with the download link as soon as it's ready. Yeah, so that's it for data extraction. And with that, I want to give back to Rainer.
Okay, thanks, Sebastian. So I'm sharing my screen, and you should now see the webODV Explorer homepage again. Do you see it?
Yeah, it's there.
Okay, so now let's actually open a data set, and we will open one of the C Data Cloud data sets that will later also be used for the linkage of multidisciplinary data sets. So this is a Mediterranean data collection made by the C Data Cloud project, as the highlighting text shows us. Opening the data set is just a click on it. And as you can see, it's really fast. It shows you by default at the beginning, when you're visiting a data set the first time, it will show you a map so that you have an overview of what you have. And now, being in the web browser, please notice this appearance in the web browser looks like as if it was a desktop ODV running. And this is by design. So the interface in the web browser has been mimicking the ODV interface just to allow the large community of ODV user to be productive from the beginning. So in the browser, left-clicking selects a station, for instance, right-clicking provides menus, and the menus depend on where you right-click on. So this is a canvas context menu. This was the map context menu. And there are menus in many other places. And it's just operating as the desktop ODV. If you have never used ODV, then there's documentation under the help menu, a concise getting started document. There's also a how-to guide that describes step by step how to do tasks that come quite often. For instance, what we will do in a minute. And there's also a shortcut key summary document, because if you look at the menus, many of these options, they have shortcut keys. And if you want to become a regular user of webODV or ODV, then it's useful to learn these shortcuts. And the summary of these shortcut keys is in this document. And then there's also a link to the full ODV user guide that applies to webODV as well. So I'm attempting to show how to arrange some interesting plots, and I will watch my clock, and if I'm using too much time, I will skip over some of the things. But let's start and get going. We want to focus on the Northern Adriatic Sea, and we want to look at the near surface salinity distribution during winter. Now, how do we do this? So first of all, we change the map. So I choose this property and I define the domain. And I had written these somewhere. Okay, so we want to go from 12 degrees to 17, 42, 46, and I press apply. And here we are in the Northern Adriatic Sea. I should say there are zoom options, like for instance this one, but if you want to have precise control over the boundaries, then the way I've just done it is the way to go. Now, if we only want to have winter data, we need to adjust the so-called station filter settings. And because this is a task that happens often, there's a shortcut key associated with it. So as a familiar user, I just put the mouse over the map and I press Alt-S, and I will get the station filter dialog. And I now want to do two things. I want to, under the availability page, request that I only see stations that really have data for salinity. And the second thing is I want to make sure that I only get stations that are within a specific part of the season. And I want to do it between December 1st and March 31. So now I've actually set two criteria, but you can see there are many more possibilities that we will not touch now. And I apply it. And what I now see as a regular user, this reads like we are now looking at 7,600 stations out of 1 million. So we have subset drastically, but we are now looking at exactly what we want. Now we want to have some data plot, and we want to look at a distribution at a given surface. And for this purpose, ODV has these isosurface values. And I'm right-clicking into it here and choose isosurface variables. And now I can define what is called an isosurface variable. So first, you define what do I want to see on the surface, salinity, and what is the surface? And it's defined by depth, and we want to look at 10 meters. And now I'm adding this. I click twice, so I delete one. And now this is defined, apply. And finally, we now want to have a setup where we have a data window showing the salinity at 10 meters. And this is a property of the entire page. So I've right-clicked on the white page, choosing layout, and I'm choosing one of the layouts templates, one surface window. And here we have water body salinity at 10 meters. Original data, and we now customize this a little bit. I'm only spending one more minute or two just to speed it up. The first thing we want to do is, instead of having original data as colored dots, we now want to have a gridded field. And I want to use the advanced DIVA gridding. So I have no time to explain these things, but and here we see this. We now notice that the color range is too wide. This can be adjusted by right-clicking into the data window, Z-zoom. This now allows to zoom into this color bar, and I'm just selecting this part. And I'm not going any further, but this is maybe sufficient for you to see how ODV and webODV alike works. And actually, what are we seeing? The bluish color is the low saline water, the yellowish, this part, very high saline water. And obviously, we are tracking the river water coming from the Po River estuary here, which affects the northwestern basin of the Adriatic, but seems to flow right next to the Italian coast, quite far detectable. And one question that when we are linking multidisciplinary data sets, we want to ask the question or test the hypothesis, do the nutrients that are discharged with basically any river discharges nutrients with its load, do the nutrients coming from the Po River water actually stimulate chlorophyll production or biological productivity in the ocean? And this will be the topic that we will ask ourselves when linking multidisciplinary data sets. I'm now coming back to my presentation. Do we again see it full screen?
Yes.
Okay, so what has been possible a few years already is that within your web browser, you could open any of these data sets that we have shown on all these webODV servers as indicated in this upper row. So this is some tracer data on the left, river discharge data in the middle, and here biogeochemical Argo data on the right. In addition, if you had ODV desktop installed and you have private data on your local machine, you could also, in addition, and at the same time, open instances of ODV desktop. And here are some examples shown here. And making publication-ready graphics from any of these data windows, that was possible several years ago already. So the new thing that was developed during Fair East is linking any data window in any of these tabs of the browser, but also any data window in any of these desktop instances, ODV desktop instances, could donate, like this window here, could donate their data or graphics elements to any of these other data windows. So that would work between different tabs in the browser, as in this case, but it could also work between browser and local ODV desktop instances. And I want to emphasize 2 ways of exchange are possible. Graphics elements that are taken from the donor and just superimposed on the recipient. And the second one is the actual exchange of the data values themselves. And I'm showing examples right now. And the first one has to do with quality control, and it's a method that helps quality control a lot. In this example, actually, we are looking at BGC Argo oxygen profiles from the Eastern Mediterranean, from those stations here in the map. And here are the oxygen profiles, and you immediately see there's a problem with the values. Every oceanographer would say it's unreal to have these big differences here. So the big question is, which one of these populations is correct and which one is not? And superposition of, in this case, CLODAP data that are trusted by the community. They are well calibrated. Everybody would say and would agree they can be taken as a reference. Superimposing them onto this graphics settles the case. So we definitely know these have problems. So exchange of graphics elements, they can definitely help QC. And as a second example, I want to come back to this salinity chlorophyll issue in the Northern Adriatic. And I want to quickly show how we can obtain this image where now the chlorophyll contours coming from satellite data are superimposed on the color image showing salinity similar to what we have actively produced just a minute ago. And that takes me to the second live demo. So let me now open this Modis Aqua image that I initiated 15 minutes ago, which actually shows chlorophyll concentrations in the same domain that was deliberately set up here to match the domain of the salinity data. And already you have the impression that looks very much correlated with 10-meter salinity that we had looked at before. But why not take the contours from this plot and superimpose them onto the other one? And in the other one, let me load a view that I have prepared before. So that's basically the image that we had created before, but now using a different color palette and small differences in the setting. So on top of this one, we now want to place the contours from the other data sets. And this is now truly, it's multidisciplinary. These are satellite data obtained from optical signals from a sensor flying high above the Earth. And the other one is water column measurements, salinity in this case. Now, how do we actually do this? And we want to take from this window, so I right-click on this window. There is this extras menu that maybe few of you know about. And it has this option, export graphics objects. And there are different kinds of objects that I could export. For instance, the sample dots, that would be dots at the actual measurement locations. In our case, we want to get the contour lines. And there are different ways where to export them to. If you want to use it often and maybe in 3 months' time, then you would export to a file to have persistence. We now just want to copy it to the clipboard and later use it from the clipboard. So I'm clicking this option. I get the confirmation they have been copied. Now I go back to the recipient where I want to add them to. Now right-click again, but now I'm changing the layout because I want to add some graphics elements. Layout, add graphics object from clipboard, clicking it, and here we are. As a general reminder, whenever changes are made to the entire layout, it's good to save that as a view, which in this case I had already done. And here I would add with contours. And if I had more time, I would say with Modis A, chlorophyll A contours, just to be very specific. Once I've done it, then actually the whole setup that I have here with all these settings, all the filters, the domain definitions, the gridding parameters, the contours that were added, they are now recorded. And tomorrow, if I want to show this to a friend, I just load this view here. So I'm kind of advertising, do this regularly. Now, if you want to have a publication because you're so proud that you really see chlorophyll is definitely correlated with contribution of river water from the Po River, and you want to write your famous paper, getting the plot out is very easy. Right-click on it, save plot as, define a format that you want to have, define a resolution. So if it's print quality, you have a high resolution, and you just do it. And the image has arrived on my PC. Trust me. And now I want to go back to my presentation, slide presentation, and want to say a few words about the other way of linking multidisciplinary data sets by really exchanging the data the data values themselves. And for this, this is under development. This will be available in a few months' time, and it will be equally simple as the exchange of graphics element. And I want to highlight what you can do with it once it's operational by looking at repeat hydrography. So the oceanographers are very keen of trying to detect changes in the ocean. And we have classic cases like, for instance, the meteor section from 1926. So this is almost 100 years ago. A zonal section here in the South Atlantic. High quality measurements for that time. I mean, it's really exceptional what they did at that time. This section, or close to this location, has been repeated several times. Here I'm looking at a recent repeat from 2018 from a British ship. And when exchanging data, you could start with this new one, get the meteor data from the other window into it, and request to calculate something new, for instance, the difference between them. And you would obtain then an image like this one that really shows how the temperatures of the recent 2018 occupation compared to the one 90 years ago. And you can see areas where it got warmer. You could see a few areas where it got slightly colder. So this way of exchanging data and calculating new things like difference or ratio that addresses, well, important tasks in global change science. And that will be available in a few months. And that's basically, that brings me to the summary. So exchange of graphics elements, as you have seen, is fully functional in ODV desktop and also in webODV. Exchange of data blobs in a slightly awkward way of operation is available in ODV desktop already, but it will be much simplified in ODV desktop, and it will be available in webODV for the first time in a few months. Both features, they make it easy to link multidisciplinary data sets. And I'm just listing a few examples for applications like quality control, as you have seen, model data comparison I haven't talked about, and detection of temporal or spatial changes, definitely that's high on the scientific agenda. And with this, I want to close, and I'm kind of hoping for questions. Thank you.
Okay, thank you very much, Rainer and Sebastian. So we're now into the Q&A period. So if anyone has any questions, we are now open. I think, let's see. If there are any questions there, you can please type in the chat. So Sinue Torres, I guess instructions will be available, right?
Could you repeat, Rob?
Instructions. So Sinue Torres is asking if instructions will be available. Sinue, if you want, you can also.
They will.
Okay.
So once this exchange package is complete, we will definitely have a small document highlighting both ways of exchanging information between data windows.
Excellent. Okay. Next question from Barbara Segato Montero. Are there any features missing from the webODV that are only available at the desktop version?
There are a few, but I would say 95% of daily need is covered by webODV. I should say these servers that we have shown, they are operated in consumption mode. So all these data sets, as we call it technically, they are opened in read-only mode. We do not want users to fiddle around and edit and change quality flags and do all these kind of things. So this is by design. We want to preserve the integrity of these data sets and have read-only mode, which means on all these webODV Explorer servers, but also on the Argo server, all the options that ODV Desktop has for modifying the collection, they are disabled. But this is not a lack of that this is not implemented. We just need to prevent users of doing this. Actually, within the Blue Cloud program, Sebastian is developing a version of webODV where a smaller group of privileged people get read-write access, and they can actually do quality control and change the collection by doing so. So the question of the feature set has these two aspects. Some features are disabled by design because we need to protect the data set, all the editing features. And a very small number of features that ODV Desktop has is still not available in webODV, but we are trying to catch up. And the objective is to reach near 100%.
Thanks.
And if people realize that some features that are really important for them are missing in webODV, please inform us. Normally, we will do what we can to add missing features.
Okay, thanks for that, Rainer. We have another question from MyBrit who asks, how do I find the data set that includes the data I need without opening them all? So that's the question. If you need clarification, we can unmute them also.
Do I still have the... what I want to answer is, I mean, the philosophy of ODV is to have data collections as big as possible, and then allow the user to have filtering to drill down to exactly the subset they are interested in. So they will still open the full set, but this goes really quick, even for gigantic data sets. And then it's up to the user to drill down to exactly which subset they want. This is kind of the philosophy that they have. The other option is to use Sebastian's extractor to extract once the piece that they want, And I think one of the output options is ODV collection. Extract this one and then just open the smaller collection. But I'm kind of saying this is basically not necessary because filtering on the fly is so fast and efficient. I should also say, I mean, what we could do in 45 minutes is just scratching the surface. So there are so many other options I didn't even mention. For instance, sample filtering, I haven't mentioned at all. Some of the data are questionable or bad, and sometimes you don't want to have them in your data plot. And there are numerous options that make it very super simple to exclude outliers, for instance, on the fly. So we would never delete the what people call questionable or bad data, because maybe in 20 years' time, people find out they were actually the most interesting data. Only the data producer decided they were questionable. So we would leave them in, but by use of these quality flags, users can filter and apply this. So again, the same philosophy, include everything and include efficient and fast filters.
Okay, thanks for that. Next from Natasha, in addition to specifying season months, can one adjust the years?
Yes, definitely.
Okay.
It was
David.
just above the season.
Mm-hmm. Okay. From a question from Dennis, will the difference/anomaly analysis be developed for climatologies as well? For example, a bat's variable in time as difference against a bat's climatology.
It will be a generic algorithm. Of course, I mean, when bringing together data from different data sets, it's still the user that needs to decide whether this is meaningful or meaningless. So taking the, yeah. So in other terms, ODV will provide generic methods that that allows to combine data from any two windows, whether it makes sense or not, and allow to calculate the difference, whether it makes sense or not. And it's up to the user actually to have a good hypothesis or a good strategy on and knowledge on why he or she is doing it like this. But it will be generic.
Next question from Amber, and this one I can answer. Will the recording of this webinar be available? Yes, Amber. This will be published within a week in the webinar page in the FairEase website. So just go to the event section. Likely you'll have to go to the past events, and then you should find that there from next week. Actually, the slides that Reiner and Sebastian have presented should already be up there, and the recording will just take a bit of time to process. Next from Aaron, what kind of projections does ODV/webODV support? For example, Antarctic, stereographic, or Spielhaus projections.
Okay, I think I can show this live. Do people still see my screen?
Yes, I see the direction there. Yeah.
Map properties. So
yes.
we used the domain page previously just to define the domain. There's this projection page, and this shows the full list of supported projections. So it has Mollweide Mercator, and it has several orthographic. Why not switch instantly? Well, here in this small domain, it didn't make a big difference, but that's the way to change projection. You have seen the list of available projection and how easy it is to switch between projections.
Next, is there any platform where videos are available? How to use ADV?
Sebastian has produced quite a number of tutorial videos, and maybe Sebastian, you point people. Can we provide in the material to participants an additional files with interesting links?
Certainly. So we would just update the webinar event page, and then we can add their additional reference material live from the webinar. So if you send that to me, I can put it up next week.
So Sebastian, can you
Yes.
provide these links?
Of course. And maybe what I can add is there are a couple of webODV implementations where we have created some videos. And this is, for example, for the Argo, for the Mosaic, and we have one special webODV for hot data where there's a bit more of hot data from Hawaii Ocean Time Series. And so if you are inside these webODVs, you will find links in the navigation bar named videos. You can click on those and you will get the videos.
Okay. Next question from Matteo. So is it or will it be possible to upload personal data sets on webODV in a personal workspace?
This question again goes to Sebastian, and work towards this is happening within the Blue Cloud project. But Sebastian can say more.
Right, it's in the Blue Cloud project where it's let's say a prototype at the moment, but there is one other webODV which is also very, let's say, preliminary and experimental. And it's called the HiFIS webODV. You find it on the webODV homepage. I think it's down at the bottom. And you can give it a try there. We have an import service and also videos who explain how to import own data. So, but I have to say it's all very new, but I would be happy if you try it.
Okay. Thank you. Next, we have a question from Sinue. In the example of a section showing differences between a recent expedition and a years back expedition, does ODV match the grid of the data points, or would one need to do so beforehand?
No, this is done behind the scenes. So of course, the new data. Let's go to the new data here. The sampling locations do not match with the sampling locations of the other representation. So that's quite normal that they never match. So mapping of data onto the other grid is always necessary. And ODV uses this DIVA gridding tool to do so. So this mapping, but it happens behind the scene. And the user doesn't have to take care of it. But it's an important step that is dealt with.
Okay. Next, we have a question from Nicholas Metzel. In case we need further clarification, we'll just provide you the floor. But here's the question, maybe you understand it better than I do. How do we refer to explore ODV in the famous paper on the Adriatic?
How to cite? Is that the question?
Maybe, Nicholas, are you able to unmute and maybe just clarify a bit the question?
Yeah, how to cite.
Hi.
Okay, every page, like for instance, the webODV Explore somewhere has rules, I think under usage agreement. So it gives you the right to use this for all means, but you need to have this citation. And in the case of Argo, Sebastian also has the Argo program requires, if you use Argo data, that you also acknowledge the Argo program, and they have phrases on how they want you to do it. but that is also listed on the web page.
Okay. Next question from Naaman. Is the 4D tracer plot, so latitude, longitude, depth, tracer, is this option going to be available soon to general users, or is it already available? And he mentions that he has seen these great 3D tracer plots advertised in the GeoTraces website.
Okay. So ODV itself and webODV itself does not have these 3D scenes that GeoTraces is publishing. So here the answer is no.
Okay. Next question from Aniket. Can you select different month combinations for different data sets, like mean JJAS/DJF?
I'm not fully understanding.
Aniket, if you're still live with us, I think you can maybe help clarify the question a bit more. You can unmute and speak.
I think I see the question. Is it Aniket Dar?
Yes, exactly. That's the one. Yeah.
Okay, so it has to do with the filtering, different data sets. Okay, so in any view, like here, I can define a specific time filter. One of the previous questions had to do, can I define an absolute time window? And the answer was yes. And here you would specify from when until when. And here in the season, you are specifying an arbitrary but contiguous time period. So in this case, it would be from December 1st until March 31. And for a given filter, station filter, you can have just one. But I could have a second view of these data in the Northern Adriatic and look at summer data, for instance, and have a different filter. Does that, I'm not sure whether this answers the question.
Hopefully so. Aniket, if you need further clarification, I mean, just ping us in the chat. Although we are running quite close to the time now, but I think we can take a few more questions in the chat. So I see a question from Erica. Where can I find the CHL-A data? So hopefully you can.
So these chlorophyll data from the satellite, we obtained from the Copernicus data system, and they allow actually, they have huge coverage. I mean, these satellite data, they are high resolution spatially, but also temporally, and have very long time series. So the full set is gigantic, but they allow subsetting the region and the time window of what you're actually interested. And what I did at the Copernicus data site, defined this region, and I had a time window of, I think, 2 years that I wanted to look at. And then they give you the subset, and this is the one we have been looking at. So it's Copernicus, basically. Google Copernicus EU.
Next question from Peter. Is it possible to add bathymetry data as contours to a surface plot?
So like the 1000 meter depth contour or something like this? And the answer is yes. I would define in the map the 1000 meter depth contour and export as contours and just overlay on this one. I'm not sure whether that was clear, but
yeah, Peter, if that's Peter Matzerath, I think. If you need further clarification, just feel free to unmute and clarify now. But meanwhile, maybe we can get to the next question. So where do we get the videos on how to use the tools? So I think it's more in tutorials if there are any. I mean, for sure, this webinar recording will be up on the events section. But I don't know, Rainer, if if there are any tutorial videos for the more in-depth.
Well, as we discussed previously, Sebastian will provide the links to the existing videos, tutorials that we have.
Excellent. Okay, so I think that's it. I don't see any more questions from the audience. We are slightly over time now, but I guess the only thing really to say is that we're seeing a lot of compliments from the chat. So aside from the questions that have been coming in, it seems people are really appreciating the tool. So thank you very much for this excellent demonstration of some of just a few functionalities. Indeed, you did mention that there are actually a lot more, and we were just scratching the surface today. Now, maybe just before we close, I just want to remind everyone that actually, we have mentioned Blue Cloud previously, and we do have another upcoming webinar on the 28th of August from 10 to 11:30. That's Central European Time, Advancing Open Science, Interoperable Data Access, and Cloud-Based Workflows. So if you like this webinar, do make sure to join for that one if you're not on holiday. So we'll be happy to receive and see you there. Before I end, I don't know if there's anything else that our colleagues would like to say or share before we close. Maybe Rainer first.
Well, I want to thank everybody for joining the webinar, and please go ahead and try these things. If things don't work, send us friendly reports. I think we have a history of trying to deal with these feedbacks as good as we can. So please go ahead and don't be shy to give us feedback, even if negative.
Excellent. Thanks, Rainer. From your side, Sebastian, any last words?
So nothing more to say. Just thank you all for joining, and have fun with ODV and webODV.
Excellent. All right. Thank you very much, everyone. Have a nice rest of the day, and goodbye. See you in the next webinar.
Bye-bye.
Bye-bye.